Good afternoon, everyone, and welcome to another episode of the Swine Stain podcast. I'm excited today to present Dr. Jimena Ibagon, who will talk about nitrogen balance, reproductive performance, and blood immune characteristics of sows. But prior to that, a little bit of introduction on Jimena. Jimena grew up on a small town in Colombia, started her education there, and recently got her PhD at the University of Illinois. Now she has started working at Trout Nutrition. So, welcome, Jimena, and let's talk about your research.
Hello, Ellie. Thank you for that introduction. And hello, everyone. Today, I will share data of one of the experiments I conducted as part of my PhD dissertation. And as Ellie mentioned, today I'll talk about of the effects of dietary protein on nitrogen balance, reproductive performance, colostrum, and milk compositions, and blood immune characteristics of sows. To begin with, I would like to point out that over the past few decades, reproductive efficiency in sows has improved due to genetic selection, resulting in litters that can exceed 20 pigs. This increase in prolificacy has increased the metabolic demands for amino acids and energy during both gestation and lactation for milk production for the piglets. Soybean meal provides a balanced amino acid profile, and when combined with cereal grains like corn or like wheat, it allows formulation of diets that meet both amino acid and energy requirements in pigs. However, in addition to being a good source of amino acids, soybean meal also contains bioactive compounds such soy isoflavones and saponins. These compounds may positively influence animal health by modulating the immune system and reducing inflammatory responses during periods of disease or stress. In addition to that, data demonstrate that when protein is increased in lactation diets from 12 to 70%, the composition of the milk of sows will improve, as you can observe in that slide. Protein and the lactose improve as we increase the protein in the diets. Likewise, Lee and others demonstrate that when soy isoflavones are included in the lactation diets from 0 to 40 milligrams per kilogram, some antioxidant parameters of the sows will also improve. However, the use of crystalline amino acids at the expense of soybean meal has increased due to the fact that the diet supplemented with free amino acids can reduce crude protein concentrations, which has been associated with improved in good health and reduced nitrogen excretion. In addition, diet cost may also be reduced if the price of crystalline amino acids is favorable, because diets can now be formulated using both indispensable and dispensable amino acids available in the crystalline form to meet the requirements of gestating and lactating sows. However, it is unknown if low-protein diets containing crystalline amino acids can support the same reproductive performance, litter growth, and immune status of the sows as feeding diets that are based only on corn and soybean meal and not crystalline amino acids. Therefore, an experiment was conducted to test the hypothesis that diets based primarily on corn, soybean meal, and not crystalline amino acids will result in improved reproductive performance and immunity of the sows compared with diets with less soybean meal and more crystalline amino acids and corn. So now let's move on to the materials and methods, and I will first describe the experimental diets. During gestation, two diets were formulated. Both were based on corn, soybean meal, soybean hulls. The low-protein diet contained more corn and less soybean meal with supplementation of crystalline amino acids, while the inclusion of soybean hulls remained constant between the two diets. During lactation, both diets were based on corn and soybean meal without soybean hulls. The low-protein diet contained more corn and less soybean meal and was supplemented with crystalline amino acids. Now, moving to the animals and feeding strategy, we have a total of 154 sows and gilts in this experiment. The animals were allotted to the dietary treatments using a randomized complete block design, and they were 8 blocks, each containing between 18 and 20 sows. The feeding of the gestation diets began on the day of the breeding, and during gestation, the sows were fed at 1.5 times their metabolizable energy requirement. From the 154 animals that were initially assigned to the experimental diets, 9 sows, with parities 2 to 6, were placed in individual metabolism crates from day 45 to day 56. The initial 3 days in the metabolism crates were considered the adaptation period to the crates, while urine and fecal materials were collected from the following 5 days following the marker to marker approach, and the collection stopped when the second marker appeared in the feces. On day 104, the 154 sows and gilts were moved to the lactation unit, and they were housed individually in farrowing crates. Sows were fed experimental lactation diets starting the day they were moved to the lactation unit. They were fed as in gestation from the entry to the farrowing unit until the farrowing. On day 115, the day of the farrowing, the lactation diets were provided on ad libitum basis until weaning. We count the number of the pigs total born, the mummies, the stillborns, and the piglet body weight, and we collected colostrum. Blood and milk samples were collected from all sows 14 days post-farrowing and on the day of weaning. Both sow and piglet body weights were also recorded on the day of weaning. Now let's move on to the statistical analysis. Data were analyzed using the mixed procedure of SAS. The experimental unit was either the sow or the litter, depending on the variable analyzed. Diet was included as the fixed effect, and block and replicate within block were considered the random effect. Least square means were used to separate the treatment means. Okay, now let's move on to the results. And to begin, I would like to set up my slides. Throughout the presentation, the high protein diet will be shown in blue and the low protein diet will be shown in orange. This color scheme will remain consistent until the end of this presentation. Let's start with the nitrogen intake in the gestation period. As expected, the high protein diet had greater nitrogen intake than the low protein diet. But it is important to remember that both diets were formulated to meet the requirements of all indispensable amino acids for gestating sows. Moving on to the nitrogen excretion in feces and urine, we can observe that sows that were fed the low protein diet had reduced nitrogen excretion of feces and urine. However, when we evaluate the apparent total tract digestibility of nitrogen, we observe a significant effect of the diet. This indicates that the additional nitrogen supplied in the high protein diet was effectively absorbed, and that the difference that we observe in excretion is not due to a reduced digestibility, but maybe due to an increased nitrogen availability in the diets. Okay, now let's talk about retention of nitrogen expressed as grams per day. Results indicate that nitrogen retention increased with the high protein diet. This may suggest that the retained nitrogen could potentially contribute to protein deposition or support gestational demands of the sow. Even though urinary nitrogen excretion was greater in the high protein diet, the low protein diet did not compensate by the retaining more nitrogen. This indicates that producing dietary protein decreased overall nitrogen retention rather than improving nitrogen efficiency. Okay, now let's move on to the lactation. It has been reported that excess of energy in the diet can result in reduced intake during lactation. But here you can see in this graph that sows had no difference in feed intake from day 1 to day 21 of lactation when they were fed the high or the low protein diet. In terms of the sow body weight, despite of the reduced protein and nitrogen retention in the low protein diets, we did not observe any differences in the weight of the sows at 24 hours after the farrowing and either differences on the weaning day. And talking about the reproductive performance, we didn't observe any differences in the number of pigs born or in the number of pigs weaned between the two treatments. In addition, litter average daily gain was maintained across both groups of the sows. Let's talk about mummified pigs and stillborns. We didn't observe any difference between the high protein diet and the low protein diet in terms of stillborns, but a tendency of more mummified pigs were observed in those sows that were fed the low protein diets than in sows that were fed the high protein diets. We also observed differences in milk composition. Sows fed the high protein diet had greater concentration of protein and fat in the milk. In addition, IgG concentrations were greater in the milk of sows that were fed the high protein diet. These results suggest that increased dietary protein during gestation and lactation may enhance milk nutrient density and immune quality, which could possibly influence piglet growth and immune status of the piglet during the early post-weaning period. To finalize, let's discuss a little bit about the immune and oxidative status of the sows. Malonaldehyde was greater in sows-fed the low-protein diet, suggesting increased oxidative stress, while glutathione peroxidase was greater in the high-protein diet, indicated a better antioxidant defense and response. However, malonaldehyde values were below those typically observed in sows under heat stress, indicating that the sows were not under extreme oxidative stress challenge in this experiment. For cytokines, although most cytokines were not affected by the diet and there were not differences, the IL-4 was greater in sows fed the high protein diet. IL-4 is generally associated with anti-inflammatory responses and immunity, which may indicate a shift in favor of the immune profile of the sows receiving the high protein diet. With that, we came up with some conclusions, and the first one is the nitrogen retention is greater in gestating sows fed the high protein diets, and this will help with the gestational needs of the sow. Also, we observe a tendency of more mummified pigs in the sows that were fed the low protein diets compared with those that were fed the high protein diets. Malonaldehyde was greater in the south-fed the low-protein diets, which may suggest an increase in oxidative stress in the lactation period. And glutathione peroxidase was greater in the south-fed the high-protein diet, which may suggest a better defense for the oxidative stress status of the sows during the lactation period. With that, I would like to thank the United Soybean Board for the funding of this project and also the State Monogastric Nutrition Laboratory for the help in conducting this experiment. And if you want to know more about this experiment or more experiments conducted at the State Monogastric Nutrition Laboratory, please reach out to the nutrition.ansci.illinois.edu. Thank you so much. See you in the next podcast.